In this video, we're going to learn how to use a correlation matrix and the simulation table. So let's begin by understanding the model. This is a very simple profit model. It's total revenue minus total cost equals profit. We begin with volume and a unit price. The product of these two values gives us the total revenue. Then there's unit cost. Unit cost times volume plus the base cost, which is a constant, yields total cost. Total revenue minus total cost is profit. And the profit divided by total revenue yields the profit rate. Notice that the base cost is certain and our other three inputs, volume, unit price, and unit cost, are all uncertain. So let's examine these distributions. The distribution of volume is a normal distribution with a mean of 500 and a standard deviation of 50. The unit price is a triangular distribution. This triangular distribution was generated in a different fashion, however. You'll notice that the bottom value was $50, the top value was $84, and the most likely value is $75. These are designated here, G3, I3, and H3. The bottom value was a 5 percentile. The top value was a 95 percentile. These are designated as G1 and H1. The static value, the value that you see when the Monte Carlo process is turned off, is $84. You would use this type of triangular distribution when you don't feel comfortable specifying an exact maximum, an absolute maximum, an absolute minimum. So this way you can estimate the 5th and 95th percentile, and it allows that there's some small probability that the actual value is beyond that range. Unit cost was calculated in a similar fashion, using a minimum value of 30, a maximum of 65, most likely of 45, with the same 5th and 95th percentiles. So let's now run a simulation of 5,000 iterations. That takes just a moment here. And we now look at the profitability. The probability that this project will yield a negative profit is 45%. That's very high. Now, when we did this calculation, we assumed that all the values were independent of one another. But that's not always the case, and it's often very important to show dependencies. For example, volume and the unit price may be related. The greater the volume, the lower the unit price. The lower the volume, the higher the unit price. So we could imagine that there's a negative relationship between volume and unit price. If we wanted to include that in our model, we would select all the variables that are interrelated, in this case just volume and unit price. We would come over here to the Define Correlations icon, click on it, and select Define Correlation Matrix. This gives us a matrix that has ones on the diagonal, and you would ordinarily just fill in values below the diagonal. So let's select this cell here. Volume is the column heading and unit price is the row heading. So this is the relationship, the correlation between volume and unit price. And we've said that we believe that that's a negative relationship. And let's make it a minus 0.8. So that's reasonably strong. If you look at the icons at the bottom of the correlation matrix, in particular, This shows scatter plots, and select on it. This shows you what a negative 0.8 correlation would tend to look like. And we're thinking, yeah, that's pretty much what we're expecting. A negative relationship, reasonably strong, but not a perfect relationship by any stretch of the imagination. So we're going to say OK to this. We are prompted to select a location for the matrix. We say OK. Indicate we're going to use cell E13. Click OK, and the matrix is written in here. So once more, we're going to take profit and run a simulation of 5,000 iterations. That takes just a moment. Here we see a very close 44.9% is below zero compared to 45%. But there might be times when we would want to compare the model with the correlation to the model without the correlation. So down here, I'm going to put in a correlation of minus 0.8, minus 0.6, and 0, just to indicate that there are 3 different correlations that we would like to try. In this cell here, I'm going to enter a risk sim table. And I'm going to indicate that you should use these 3 values that I just identified in this sim table. So notice up here in the function line, risk sim table F17 through H17. So what this is going to enable us to do is we're going to do 3 simulations, one with minus 0.8, one with minus 0.6, and one with 0 as the correlation between volume and unit price. Excuse me here, I just accidentally erased my risk sim table. Let me restore it. And what I need to do is I need to substitute this 0.8 with my sim table. So in the matrix, I just type an equal sign and an E17. And now I have a sim table in here. I now want to run 3 simulations. That's not an option, so I'll have to type it in. And I put my cursor in the profit. And now we're going to run 3 simulations. The first with minus 0.8, the second with minus 0.6, and the third with no correlation at all. I have a new icon down here at the bottom of my output. Select simulation number to display, and you see I can show simulation 1, simulation 2, or simulation 3. I can also show all the simulations at once. So simulation 1 had a correlation coefficient of 0.8, negative 0.8. Simulation 2 has a correlation coefficient of negative 0.6, and correlation 3 has a correlation coefficient of 0. So I'm going to go to graph options, and I'm going to select delimiters, and I'm going to ask for 3 delimiters. And now I can compare. We have 44.3% below 0, 45.3%, and 44.9%. They're not very significant differences. So in this case, it didn't seem to matter a great deal whether we used a correlation or not. But here in this simple model, you have seen how we can use a correlation matrix to relate two or more variables, and how to use the simulation table to examine the sensitivity of our results to different correlation coefficients.